In this video, we're going to talk about the differences between zeroing your Z on the material surface versus on the bed. So we're going to talk about the pluses and minuses of each. Stay tuned. So this is a video I've been wanting to do for a while. I get this question a lot from people. What's the best place to zero your Z-axis or touch your tool off to your material? Should you do it off the top of the material or should you do it off of the bed? Now, before I go any further into this video, I want to be clear about a couple of things and terms that I'm talking about through the video. One of them is if you in Vectric, there's the Z0 position. It says material surface or machine bed. Well, material surface is pretty self-explanatory. What I'm talking about is that whether the material is sitting on the machine bed or on a spoil board, you're going to use your tool length sensor and touch off Z0 to the top of the work material. Okay, so then in those cases, then you're using material surface. Now, when I talk about zeroing off of the machine bed, right, because this says machine bed here, I'm actually referring to one of two scenarios. So the first scenario is Z-zeroing off the actual machine bed, which in this case, I've got my work material sitting on the machine bed and my tool length sensor is measuring Z0 from the actual bed itself. The other method that I'm talking about is when you use a spoil board. So in this case, we are zeroing Z off of the machine bed setting, but the tool length sensor, instead of being directly on the machine bed, is on the top of the spoil board because the workpiece is sitting on the spoil board. So when we refer to machine bed, there's the two scenarios. It's either going to be on top of the spoil board or on top of the machine bed. Now, if you're using a vise, it could be on top of the vise as well, or whatever the material is sitting on. Basically, just think about it. Whatever surface the bottom of your work material is on, that would be considered the machine bed. And then when you measure off the top of your work material, that's material surface. There is also one other scenario that I can think of that you may run across depending on what machine you're using. And that is if your CNC machine has a tool length sensor that is fixed or in a fixed position on your frame. Sometimes it's a fixed position on top of a tool rack. Sometimes it's a fixed position on top of the machine bed, and sometimes they've got it fixed like this, where the top of the tool length sensor is actually level with the actual machine bed. Now, in a case like this, what usually you'll have is some sort of a macro or something in your software, in your machine control software, where you have to tell it what the thickness of the spoil board is. So you would actually have to measure the spoil board, or if you surface the spoil board, then you'd have to remeasure it and then go into that macro file or profile setting, and you'll have to add the new value of the thickness of the spoil board. Because in this case, when you touch off on your tool length sensor, you are in fact using machine bed. But if you don't have a macro or profile that adds in the spoil board and your material is in fact on a spoil board, when you start to machine it, the machine is going to think that the material is sitting on the bed and not on top of the spoil board. So you have to have a setting in there. And the best thing to do in that case is if you have a fixed sensor, just contact your machine manufacturer and ask them what you should do about setting your Z0, and if there's some location that you're going to have to put in the value of the spoil board. So I just want to be clear about that before I proceed into this video. The most common that I've seen with people is that they always put their sensor or they touch off to the top of their work material. And there are cases where that's okay. If you have a spoil board on your machine and you're cutting all the way through the material, you might be adding 10 or 20 thousandths to the cut depth, cutting into your spoil board slightly. So if all you're doing is profile cutting, like for instance, say a puzzle, where you're cutting all the pieces out directly, and you measure your material and maybe the material surface varies a little bit, but you just add some extra so that you're actually machining into the spoil board to get a clean cut on both sides, then Z-zeroing off the top is no problem at all. Now, one of the things that we have to look at here in this example, I'm measuring my material. It's at 1.27 inches. Now I'm thinking that this is 1 1/4, but it's actually 20 thousandths over, and my desired thickness is 1 inch. In this particular case, we have to figure out, is this really the best way to do this? If I use my tool length sensor on the top of the material and I take off 1/4 of an inch because I'm assuming this is 1.25 inches, then I've got an issue. Now, if I measured this, or if I had a way of measuring this, and I know that it is perfectly 1.27 across the entire thickness of this material, then I could simply change this number to 0.27 and I'll end up with a 1-inch final thickness. But that's highly unlikely, especially with wood, where, maybe if you're using plexiglass or plastics or aluminum, it would be more precise. But if you're working with wood, there's always a chance it's going to fluctuate. So in this particular case, if I were to go ahead and cut that the way I had it, and my original material thickness was 1.27, and I remove 1/4 of an inch, my final thickness on this part is going to be 1.02, which is going to be over by 20 thousandths. So depending on what you're doing, if that final thickness has to be an exact number, then zeroing off the material surface is probably not going to be the best option for you. So one thing you can use zeroing off the surface for is, say you've got a piece of material, as an example, maybe you're doing another puzzle piece, right? And so you've got some profile cuts that have to cut all the way through, no big deal. You're just going to add a 20 thousandths or 10 thousandths to it and cut in your spoil board. So your profiles are taken care of. But let's say that you have a pocket that has to go in, like a recess for a piece to fit into from the surface of your material, and it has to be exactly 0.4 inches. Well, if you're measuring off the material surface, then your chances are that this depth is going to be pretty consistent. Now, that can vary too. If you're using wood that has thicknesses that vary, like for instance, a sheet of plywood, maybe it's there's a 10 thousandths or 20 thousandths difference between one end of the 4x8 sheet to the other, and you happen to pick up on a low spot, then that low spot's going to be accurate at 0.4, but when you cut into a spot on the material that's thicker than that, then your depth is actually going to be greater than 0.4. In a case of plywood, though, it's not common that you would normally surface the entire sheet of plywood with a fly cutter in order to make sure that you get accurate Z depths. You know that there's going to be some tolerance, and that's just kind of fit into it. So if you had a part that had to be glued into this pocket, well, and you're off 20 thousandths, it's really not going to make too much of a difference. You're probably not even going to know that because the glue is going to fill up some of that space. But when you're talking about more precise parts and things that are smaller and they have to be exact, if you're doing aluminum parts or plastic parts and everything's got to fit perfectly, or if you're working with rough cut lumber and you need to surface that to make sure that, for instance, if it's say 1/8 of an inch thick lumber and you want to get a final size of 0.75, well, then what I would do is I would put the material on, I would surface the top, measuring from the top of your material with the tool length sensor. I might take off a 1/16 of an inch until that entire top is flat. Then I would flip it over, but the second time I would actually measure off the bed, because now that I have a flat bottom surface, I want to make sure that my material is actually going to be that size from the bed up. Okay, so that's really important, that distinction between the two. So as an example here, I have let's see, here's a piece of material that I measured, and it's roughly 0.125 or 1.25, and here the dashed line represents my desired thickness, so I need a final dimension of 1 inch. If I want to guarantee that is 1 inch, then what I would end up doing in this case is I would actually measure off of the bed. And when I set this job up, I will set it up and I will set my material thickness to 1.25, and I would take a 0.25 inch cut pass depth, and that would leave me with 1 inch exactly. Now, if I were to do this from the surface and I put in 1.25 and I do pass depth of 0.25 inch, then I should theoretically get 1 inch, but if that top surface varies at all, this number could be a little over or a little under, depending on. So if you want a guaranteed thickness of a final part, then going off the bed is always the best way to do it. Now let me show you how we would do that. So in this particular job, I've got a 4" by 4" work area set up, and I've got a thickness of 1.25. So that's set up in my work material. I am using a single-sided job, and I'm going to zero off the machine bed in this case. Now I created a pocket toolpath, and I created a vector that's about a 1/2 inch larger than the work material because I want to make sure that when I surface this, I am going past and I don't end up with material in the corners that hasn't been cut. So I set my start depth at 0 and my cut depth to 0.25. So again, doing the math, I have a material size of 1.25. I'm removing 0.25. That should leave me with 1 inch left over. Okay, I've set my end mill up, and I'm just doing a raster. None of that really matters for this example. So here's my material. Pay attention to right here. When I put my mouse over it, you can see that the Z says 1.25. Now I'm going to go ahead and I'm going to preview this toolpath. And I've animated it here so you can see what the end mill is actually doing. It's removing a 1/4 inch of material on here. And when this is finished, if I put my mouse on the surface, you'll see now down here that I have 1 inch as a final height. Okay, so that's how you can guarantee that you get the most accurate thickness on your materials when you use Z0 off the bed. And that's going to give you that final one inch thickness. Now, here's another case where this is pretty common. Say I've got some material on my machine that has a rough or an uneven surface, okay? If you were to go ahead and set this same example up with 1.25 inch and a 1/4 inch cut depth on it, what's going to end up happening is it's going to remove a 1/4 inch in some spots, but because the material is uneven, you'll be cutting quite a bit thicker than a 1/4 inch. So what you do is you end up putting more load on your spindle, on your machine, and on your cutter. And in some machines, especially if it's a lighter duty machine, that could be a real problem. Because you might have your speeds and feeds set for 1/4 inch pass, but all of a sudden you find yourself with an extra 1/4 inch. Now you're at a 1/2 inch pass. That's going to create some problems for you. So what we end up doing in a case like that is I would estimate that the highest spot by measuring is, you try to guess what that's going to be. If you can get to it close with calipers, that's fine. Or just round up slightly to what you think the highest spot would be. In this case, I rounded up to 1.5 inches. And again, I want to remove a 1/2 inch total because my final cut I want to be 1 inch thick. So I'm setting pass depths at 0.25, and that's what these dashed lines represent. Now, what that's going to do is, again, if I calculated my speed and feed load based on a full cut with the end mill, removing all the material at one time, then when I make that first pass and my surface is uneven, my load on that cutter won't exceed the load as if it was 0.25, but it'll be less. So it'll be full load or less, because depending on how, if you hit a thinner spot here, it's going to be less load on the cutter. Okay, this is commonly used when you're machining off rough cut lumber, or if you've got a board that has a check or a bow in it and you want to remove that, you can use the machine as a planer. Now, in a case where I have rough cut lumber, say this material was rough on both sides, well, I always want to make sure that it's sitting flat on my bed, so when I set my final cut height, I've got an accurate measurement on that material. So what I would do in this case is I would put the wood on the CNC with, it doesn't matter, I mean, if you have one side that's a preference as the final over the other, then you'll use the opposite side right now. So you put the board on the CNC, and then we would go ahead and Z0 off the top of the material and remove some amount. Now, depending on your machine or how much material you have to remove, sometimes a 32nd of an inch is all you need. Sometimes you got to go up to an eighth or more to get that level surface flat and cleaned up. So you're going to do that, and then you're going to run from the Z0 from the surface. You're going to cut down, and that's going to give you a nice flat finished surface. So now to complete the final thickness of the board, you're going to flip that over. And when you flip it over, now you've got a nice flat piece on the bottom. And so now what you would do is you would do a Z0 off of the bed, and you would set your cut depth as we show in this. So you would end up with a final thickness of whatever that dimension is, whether it's 1 inch or whatever you set. But it's important to make sure that you always plane off one side to make it perfectly flat, then flip it over, and then only remove enough material on the second side to get you your final thickness. Now, if you only have a little bit of material to work with, say you only have your board is 1 1/8 and you want to make it 1 inch, you got to be a little careful because you don't want to take 1/8 of an inch off one side. Then when you flip it over, you have a rough surface. If your intention is to have a smooth surface on both sides, you might split that and do a 1/16 on each side to get that. So it's just something you have to be careful of, when you're working with rough cut materials and things like that, or materials that might have a bow or a warp to it, and you're trying to remove that. So that's pretty much how I would set this up. Now, this particular example, let me just set this up in Vectric to show you what I'm talking about here. So we're going to go back to the job setup, and we are going to make this now the thickness of the material is 1.5 inches. And we're going to leave the Z0 on the machine bed and click OK. Now it's going to ask us to recalculate. Well, I'm going to go back in here real quick to our pocket toolpath. I'm going to change the cut depth now to 0.5 because we want a 1 inch final, and we set this to 1.5 inches. I want to go in to my tool. I want to edit this, and I want to make sure that I set my feeds and speeds up correctly for my machine. And in this case, if the machine I'm using has a maximum path step for a 1/2 inch cutter to be 1/4 of an inch for whatever that material is at these speeds and feeds, then I want to make sure my path step is set to 1/4 inch. Now, if my path step was set to 1/2 inch, then I'm going to remove all that material in one pass. However, if I want to be more on the cautious side, I could set it to 1/4 of an inch, and now it's going to make 2 passes. So you'll see that right here, that it's going to take 2 passes to clean off that surface. So I'm going to go ahead and calculate that. And you can see now here are my 2 passes. So I've got the first pass is going to come through, that's this top blue line, and then the final pass, which will give me my final thickness. So if I preview this now, you'll see here's the first pass that we're making. With the machine, we're removing a 1/4 inch of material at this time. And then we're going to come back as soon as that's done, and we're going to go ahead and take the second 1/4 of an inch off on this layer. And again, this is keeping a constant load on that cutter and on your machine by doing it this way. You don't have to worry about the variances on the top of the material. So you can see here, if you look down here, my final cut height now is 1 inch. So that's pretty much how I would jump on a job back and forth between zeroing off the bed or zeroing off the surface. Now, to take a look at, I have some final notes here. If I'm going to zero off the material surface, it's best used when the material is an exact thickness. So if I measure this material and it's exactly, say, again, 1.27, then I know I can remove 0.27 and end up with a 1 inch final. Okay, that might be okay on smaller parts, but again, a sheet of plywood, it's a little bit different. If you're using MDF, it tends to be a little bit more stable, but you could still get some variances of 5 or 10 thousandths across the board. It really just depends. Wood is a living material, and it has the ability to vary. However, if I was using, say, cutting a piece of acrylic, and I know it's a uniform thickness all the way across, I'm more comfortable machining off the surface because I know that the material is a constant thickness. One thing you do want to make sure, though, with either Z0 off the material or the bed, is that you want to make sure that your spoil board and your bed are level. So if you're using a spoil board, you want to make sure you surface that so it's level and parallel to the gantry. So that way any material you put on there is level to the gantry, and you're going to get accurate cut depths across the surface of your machine. So Z0 off the material is also good when you're profile cutting through the material. If you're going to profile cut into your spoil board by 10 or 20 thousandths, then it's quick and easy to just zero off your surface, knowing that you're going into the spoil board anyway. So that way there you'll ensure that you'll get a nice clean top and bottom cut. And a lot of times when I'm profile cutting, I'm always going into the spoil board a little bit, because especially when you're using woods like plywood, you want to make sure that you're going past, and if I'm using a compression bit, I want to go slightly past the bottom to be sure that I'm pulling chips up from the bottom and I get a clean cut. So if you're doing cabinet making and things like that, Z0 off the material is okay if you're doing profile cutting, and especially if you're using a compression end mill, you're going to get a nice finish on both sides. It's best suited for a first pass of surfacing rough material. So again, if you have a rough board that you're putting on the machine, to Z0 off the top and then remove a given amount of material is going to give you a nice flat surface to work with. Then when you flip the board over, now you're going to go and zero off the bed so that you get an accurate final thickness. If you want to go to zero on your machine, then you have to use material surface. And I'll explain that more in a second. Also, the material surface is, in my opinion, it's best for engraving. If I'm going to engrave, or if I'm going to say etch a spoil board or a circuit board, or I'm going to engrave into a piece of aluminum or plastic where my thickness needs to be, my engraving depth needs to be uniform, the most important thing there is making sure that the surface of the bed is level. So if I was going to engrave something, I would always put a spoil board, a piece of MDF or something down, and then surface that. That way I'm sure that that's level. Then when I put my material on, I would Z0 off the top of the material, and I would say, okay, I want to engrave 5 thousandths or 15 thousandths, whatever it is, and I'll be sure I have a uniform engraved depth all the way across my material. But that's the key to that, is making sure that you surface your spoil board first. If you don't do that and it's off by even a couple of thousandths, when you look at your final engraving, you're going to notice it's deeper in some spots and lighter in another. So always make sure that you do a surface and get your spoil board perfectly level before you're doing engraving jobs. Now, some final notes: if you're zeroing to the bed, zeroing on the bed is best for final project thickness accuracy. So again, because you're measuring from the bed up, you're guaranteed to get an accurate thickness that way. So you're gonna always put in your material thickness, subtract whatever you want to get your final thickness. When you're done, as long as your bed and your spoil board and everything is level, you're going to end up with a final part that is should be exact, if not extremely close to what your final material thickness is supposed to be on your project. It's best for the final side when you're planing rough material. So again, like I said before, if I was planing a rough board, I would go from the surface down on one side, and then once that's flat, I flip it over. But now once I got the flat side down, I know now that I need a guaranteed material thickness. And in that case, I would then zero off the bed and then put in what I calculate out what my final thickness is going to be. That way I can be sure that that's what I'm getting. So when you're playing, it's surface on the first side, flip it over, and then off the bed and measure up from there. When you're zeroing off the bed, you have to be very, very careful not to hit go to zero. And the reason for that is, if you say this orange box here is my material, I know I said it's a machine bed, but let's just say it's the material, and I am setting my XY0 to the middle of that, so it's right here roughly where my pointer is, and I'm going to zero off of the surface of the material, and I hit go to zero, my cutter is going to be right on top of the material at the center location. No big deal, that's what we expect. However, if I set my XY0 to the center location and I Z0 my end mill over here to the bed instead of the surface, now when I hit go to zero, what's going to happen is the end mill is going to move over to the center of the material, and it's going to try to plunge straight down to the bed. And, that could end up breaking a tool, damaging your machine, and ruining your material, because you're going to put a heck of a dimple in it when the end mill plunges in, especially if it's not running. So, you got to be very careful not to hit go to zero when you're Z-zeroing off of the bed. And again, you'll always want to make sure that your spoil board and your bed is surfaced and level. If you're measuring off the machine bed and or off the surface. Now, when I say machine bed, I could also be talking about your spoil board. What I mean is the bottom of the work material, not necessarily the bed of the CNC itself. If you're measuring off the actual bed of the CNC and you have a 3/4 inch spoil board on top of it, then you're going to have to add that to it. So what I'm talking about is always at the bottom of the material, whatever that surface is. So if it's the machine bed, fine. If it's a spoil board, then it's going to be on top of the spoil board. So you want to make sure that that's level, because if it's not, and you say that you're expecting a final size of 1 inch and one side of the bed is lower or higher, then it's not going to be an inch, because your gantry is always moving at a level, even plane. And if the bed is off, that's going to affect the thickness or the final cut results that you have in your work material. So I hope this helps, this tip. I know that I went through a lot of it quickly. If you have any questions or need any clarification, please put some comments down below, and I read those every day. And I'll do my best to either have a follow-up video or try to explain it better in the comment section. If you like this video, please give it a thumbs up. And if you haven't subscribed to our channel, please do me a favor and just hit the subscribe button. That'll ensure that every time we post a new video, you get notified as soon as it's live.